we only use it obviously for demonstrations. So typically they're around lunchtime, which helps us because it does take sort of 2 to 3 hours to get everything up to temperature and get the car running. We have water heaters, oil heaters, and obviously tire warmers as well. You don't really want to run a car with slicks that size that are cold.
Welcome to the HPO Tuned In podcast. I'm Andre, your host, and in this episode, we're joined by Dave Higgins from Kinetic Sim as well as Classic Revival. Dave is probably best known for his work in aero performance, aero development, and basically building aero components for race cars and modified road cars. That's just scratching the surface of his capabilities. So in this podcast, we dive into his background, how he got an engineering degree and how he got involved in the aerodynamics side of the motorsport industry. From here, we'll talk about his involvement with the development of bespoke race cars, building the car entirely in CAD before a single component is manufactured. Particularly here, we're talking about the collab between Kinetic Sim and Race Lab here in New Zealand, building what is going to be a replica of a BMW E21 Group 5 race car, but with a very modern take on it. And by modern take, I'm talking here about a JGTC-based GT300 full carbon fiber monocoque. On top of this, we also dive into Dave's involvement in their family business, Classic Revival, which is involved in the restoration of some classic race cars. And I'm talking some pretty well-known race cars here, including a Porsche 962 Group C race car, as well as one of my favorite cars, the Leighton House 891 Formula One car. And we talk about what's involved in doing justice to the history of cars like this, how to go about restoring a car, and what's involved in then running them. Before we get into our chat with Dave today, for those who are new to the Tuned In podcast, High Performance Academy is an online training school. We specialize in teaching people how to tune EFI, build performance engines, construct wiring harnesses. We also cover race driver education, race car setup, data analysis, and fabrication. All of our courses are delivered via online video modules that you can take from anywhere in the world, provided you've got an internet connection. And if you are interested in learning more, will put a link in the show notes to our full course catalog. And as a podcast listener, you can use the coupon code podcast75. That's going to get you $75 off the purchase of your very first HPA course. All right, enough with our introduction. Let's get into our chat now. All right, welcome to the podcast, Dave. Thanks for joining us today. And let's get started by finding out a little bit of your background. How did you form a passion for cars or get involved in cars in the first place?
So it would have initially started back when I was a small child. My father was into cars when he was younger. He did some rallying and some old Fiats and Anglias and so forth. And it was actually probably when my sister was born that things really kicked off. She was supposed to be a boy. The scans all showed she was supposed to be a boy, and my father had been looking at a 911 SC that was for sale in Auckland at the time, and he made a bet with my mother basically that if it was a girl, he was allowed to buy the 911. And yeah, my sister Sarah popped out that day, and he went down to the dealership and bought it in the afternoon.
Sounds like a good deal for your dad.
Yeah, it was one of those lucky incidences, but. Yeah, so that's sort of where it started, and he got into Porsche Club racing and raced 911s, 930s, 2.7 RS, and yeah, we just went along with that basically. That me and my brother got into racing that way. He had a Formula Junior as well, a Brabham. So yeah, we sort of were brought up at racetracks. We grew up waiting in the car or helping or watching or spending our entire weekends away racing. So that's sort of where it started.
I guess that sort of upbringing really doesn't give you too many career path options. It's in the blood. Did you get involved in racing yourself behind the wheel?
Yep. So we got involved in karting probably a bit later than the kids these days do it. We were sort of more involved sort of towards our being sort of 14, 15. I think the first time I drove a car was around the Manfield circuit, and it was a Holden Commodore V8 automatic station wagon. That was the first time I drove around a racetrack. But yeah, we got into karting probably after we did some racing. We sort of did some classic racing in Porsches and Dad's Porsches when we were sort of 15, 16. And then we got into karting, and then went on to Formula Forward. My brother did Toyota Racing Series, and he sort of continued on more down that path, racing Formula 5000 and and racing some stuff overseas. And I did the Nürburgring 24-hour race and those sorts of things. Whereas I sort of went down more the engineering path. I was more interested in the cars and the technology and that side of it than I was the competition and the winning.
So did you pull away from the hands-on driving at that point to pursue the engineering element, or are you still involved in some hands-on motorsport yourself these days?
No, I haven't raced again for probably since my mid-20s, but it definitely is something I do want to get back into. And yeah, I am restoring a race car at the moment, albeit slowly, that I hope to get back into in the next couple of years. And I do at some point want to build my own design race car that I can use locally.
Perfect, makes sense. Well, you've talked about this engineering interest that you formed from being involved with racing yourself and obviously with your father's involvement. So how did that formalize in terms of your career path, qualifications, etc.?
Yeah, so I studied a degree in mechanical engineering at Auckland University. I always knew that's what I was going to do. There was never really any question through my schooling that I wasn't going to be an engineer. It's sort of, yeah, we got towards the end of our degree after we'd sort of specialised in mechanical, and a few of us actually got together and we had a great idea to start a Formula SAE team where we were getting towards, I think we were in our third year at that point, and we thought if we did our fourth year projects on race car design things, we could start a Formula SAE team. Yeah, so that's myself and a couple of other two or three other guys basically talked the university into letting us start a team.
So we've talked to a number of guests who have been involved in Formula SAE over the length of this podcast, and I'm always pretty jealous because I never had that opportunity through the university I went to. But almost always it's an existing Formula SAE team that the university has been running maybe for a decade or more, and that becomes an iterative design. You're not sort of coming in with a completely blank sheet of paper. Am I picking it up right here that you started this for your university and there was nothing before, nothing existed?
Yeah, nothing existed at Auckland and nothing existed in New Zealand at that time. It was back in 2003 that we were having these discussions. And yeah, we essentially had to talk the Dean of Engineering back then and several of the senior professors into the fact that we thought it was a good idea. We had no clue what we were getting ourselves into. It was a mammoth effort. And to be honest, my grades suffered because of it in my final year. We got a team together. We had some amazing help by the university. It wouldn't have happened without them. They provided us an entire workshop space. We had to go find money. We had to find sponsors. And yeah, we were doing 21-hour days, leading up to sort of exam week and stuff. And yeah, we ended up making a car. We got it running. We tested it. We took it to Australia because that was our closest Formula SAE competition. And we did really well. I can't remember exactly, but I think we finished maybe 5th or something like that. But we got an award for basically, doing so well. I can't remember the name of the award off the top of my head, but it was basically for doing so well at our first go. The team's still going now, and it's really awesome to see. But I think it's taken the team a long time to do it to get a better result than we got in the first year.
Obviously, starting from that clean sheet of paper without any previous designs from years gone by, there's some benefits and some downsides to that. Do you think, other than the immense amount of work you were faced with starting from scratch, that having no prior design, though, actually benefited you in terms of getting that result?
I think we kept it very simple. And one of the big things, and it was even more so back then, is just finishing the events, actually being reliable. And I think we kept it quite simple. We used, we didn't overcomplicate any of the design. Tube frame chassis, Yamaha R6 engine, nothing was really obviously going to be broken. And we did a lot of testing with it. We didn't do delicate testing. We were told off several times for doing donuts with it when we, not really.
I didn't actually realise that there was a donut competition as part of the Formula SAE competition, but always learning something new every day.
Yeah. So that's sort of, I guess that's where I merged the engineering and my love for cars together was through that process and through that team.
So at this point, what would you say your key skills were in terms of that engineering aspect when it comes to automotive? Obviously, it's a very, very wide range that mechanical engineering covers.
Back then, I guess I concentrated on the mechanical design most. I was responsible for the suspension design, the uprights, that side of things. We had another group doing a fourth year project on the aerodynamics, another group doing the fourth year project on chassis and chassis stiffness. And we basically just put them all together to create the car. and another group was doing the engine, the sort of intake design, that side of things, dyno work, and yeah, it all sort of just came together. It's amazing it did, to be honest, because we all didn't have a clue really what we were doing at the time, but it sort of just worked through sheer grit and determination.
Perfect. Okay. Well, let's move on. So, what happened after your university days? Where did you go to there in terms of work progression?
Yeah, so after that, it was a bit disappointing, really, to be honest, because there isn't, as I'm sure you know, there isn't a professional motorsport industry down here in New Zealand. So there wasn't really any job that I could go into to use what I'd learned. So essentially, I ended up going and working in aviation. So I went straight from uni to working for Air New Zealand. I think we were the first graduate intake at Air New Zealand engineering in decades, but there were four of us who started there. And yeah, I began my career doing essentially structural repairs on airframes. So doing, studying and doing all the courses overseas with Boeing and so on and so forth, doing metallic repair and composite repairs. So it's basically stress analysis on metallic and composite structures. So that's where my career started, doing that sort of work.
You mentioned the sort of lack of an automotive industry here at a professional level, and the highest we've got in New Zealand is probably sort of a handful of GT3 cars that run in some fairly basic endurance races up to maybe 3 or 6 hours. So there's some engineering opportunity there. We do see a lot of engineering graduates who have a desire to really make a name in motorsport, therefore heading off to Australia to the likes of the Supercars Championship, or alternatively, of course, overseas to Europe. That didn't appeal. That wasn't an option on your radar.
I did have, I guess, several thoughts around going to Europe. I think at the time I might have even applied for some jobs with, I think it was Honda Formula One back then. And it was just at the time that they basically stopped, and it would have changed at that point to being Brawn. But that hadn't been announced yet. And so I think at the time, yeah, I felt like I dodged a bullet, not knowing that it probably would have been a good job going forward, because it would have been obviously Mercedes these days. But yeah, I'm quite a homebody. I like New Zealand too much, even back then. At that stage, yeah, I can't explain it, but yeah, I love New Zealand too much. I've spent time overseas. I did a 3-month stint at the end of 2003 with Rod Millen Special Vehicles in California. So I sort of did my internship over there, working out of Rod's design office, and that was really cool experience. But there's nothing quite like home. And yeah, at the time I was racing as well. So sort of 2005, 2006, 2004, we were racing Formula Ford. So at the same time, I would have had to have given all that up, which I wasn't ready to do at the time. So that sort of held me here. And let's be honest, like a job doing the sort of work I was doing in aviation wasn't a boring job. I wasn't working for sort of some of those other more engineering roles that a lot of engineers go into, mechanical engineers go into, whether it be oil and gas or...
Yeah, I mean, there's definitely there's a crossover, however subtle you may think it to be, between the aerospace and the automotive industry. So I get that. Moving on though, you're known now, and we're going to get into this for your work with Kinetic Sim, and a lot of that, or part of that, is sort of aerodynamic development. I mean, it sounds like there might have been a crossover here, but you're working for Air New Zealand, not directly for Boeing or Airbus. So I take it at this stage you're not actually doing anything in aerodynamics. Am I right, or is this sort of fed into that?
Correct. Yeah, correct. I specialised in aero hydrodynamics at university. So I did my two specializations were aero hydrodynamics and dynamics, vibrations, and structural analysis. Yeah. So I did do work in that at university, but with Air New Zealand, there was, we weren't designing planes. Initially structural repairs, but then I moved on into their interior design business, I guess, more so then. And we did a lot of work with Boeing. I spent quite a bit of time up in Seattle, up at Boeing. So we did work quite closely with them. We were doing a lot of finite element analysis back then. So we were getting really in depth into that side of engineering. But no, aerodynamics wasn't something we touched on at all. That sort of came about after about 7 or 8 years with Air New Zealand. I got the opportunity to go do some work with Avanti bikes here in New Zealand, who are a bike manufacturer. And it was basically being in charge of the engineering of all the road bikes for Avanti. But most interestingly, it started out being work on the Olympic track bikes. So that's sort of where I got to mix my experience with stress analysis and composites through aviation, but also my passion for aerodynamics through my studies together into basically creating the entire product, designing and creating the entire product myself. We would make and then we'd see the athletes ride and compete at an Olympic level. So that was sort of quite a good step for me because I really enjoy competition more so than I enjoy designing things for planes. So
Yeah, I guess it must be a bit more rewarding as well, seeing a product that you've made. Obviously, the person riding the bike's a big part of the success or failure, but still, it must be a certain amount of satisfaction if it actually does well. I mean, without going too far down that rabbit hole, the speed that these bikes are going on a velodrome, what are we talking here?
we're talking 60, 70 kilometers an hour.
So that's sufficient for the aerodynamics to have a significant impact.
Oh yeah, yeah. It makes a massive difference to be honest. The scale we're talking about is very different. So we weren't looking so much at downforce. We were purely looking at drag reduction. But we're talking about grams force of drag versus this, with the motorsport, kilogram force, not gram force. Although it's not race cars, for New Zealand, we were doing the level of work that Formula One teams were doing. We were doing wind tunnel testing. We were traveling to San Diego and Mooresville for their wind tunnels. We were doing CFD, and it makes a big difference. It makes seconds of difference at the end of a 4 kilometer team pursuit, which is the difference between winning and losing. So that's sort of where I started my aerodynamic journey, I guess, was with the bikes.
So how's that sort of led to where you are right now with Kinetic Sim? Sort of catch us up on the gap we've got in the middle.
I saw an opportunity as I was doing the cycling work. At the time, we were leasing licenses for CFD of ANZUS, the CFX, through Australia, and we basically get a month's worth of CFD, and it was costing, I don't know, $12,000 to lease the software for a month. And I sort of knew how many projects we had coming up with the Rio Olympics and the investment that the company was putting into bikes for Rio. So I saw an opportunity basically to start my own business and purchase the CFD license from ANZUS and essentially just lease it back to Avanti itself as a way of essentially saving them money and me getting into that sort of consultancy role of doing that work, which then I could take on and apply to motorsport as well.
Sure, yeah, it makes sense. That software you've mentioned, ANSYS, is that kind of the gold standard industry-wide for this sort of work, or are there other options?
There are other options. A lot of people create their own code and create their own interfaces or so on, but ANSYS is it's probably one of the biggest CFD ones you can buy, and it's a ready-made product. You don't have to go and be a software engineer to make it work. So, Porsche use it. You'll see ANZUS stickers on the side of the new 963 LMDH cars, and Emirates Team New Zealand in the America's Cup, ANZUS is what they use. So it is sort of the gold standard in many ways, but I'm sure there are still some other ones out there that are just as good.
I mean, obviously it's a complex field, and it's certainly one I don't sort of say I've got any understanding of at all. The last probably decade or so, we've seen the prevalence of software that's basically free for personal use, like Fusion 360 for 3D modeling. Is there anything sort of at that more sort of enthusiast level that could be used to sort of get a leg up in that field and get started, or is it really the complexity involves multiple thousands of dollars?
I think if you're trying to sort of compartmentalize parts within a car, for instance, you can probably look at some stuff using those more affordable or sort of add-on CFD packages like they have with SolidWorks. They've got an add-on package. But when you're trying to do a complete car, the size of the car and the scale of the amount of elements, and it gets massive, and those smaller ones really can't handle. You're just really going to struggle to get proper divergence. And yeah,
that makes sense. All right, so Kinetic Sim as it is today, can you give us a bit of a 30,000 foot view of what the business is, what services you're offering? Is it solely you? Yeah, tell us all about it.
Yeah, so it's solely me, and really it sort of started out as it continues. Although I initially created it for aerodynamics, for this, as in the name, simulation, for the CFD work and the FEA simulation work. But it's sort of grown from there a lot now to be far more about design and engineering, more so than it is about CFD. an FEA. Like I'm no longer just doing aerodynamic packages for cars. I'm now at the point where we're essentially doing, well, in some cases, complete cars from scratch. So it's sort of grown in that respect, but hasn't grown in scale. It's still just myself.
I guess there's still only so many hours in a week as well, so that's going to artificially limit the projects you can choose to get involved with.
Yeah, I think, and to be honest, like working from down in New Zealand, it is a struggle to get work from overseas. It's always easier to find someone in Europe than it is to take a punt on someone from across the other side of the world. So the number of projects and the amount of work really is quite limited down here. So because of that, there hasn't really been a need to scale. I can't say that there's a lot of the sort of level of work that I do down in New Zealand.
Let's talk a little bit about some of your notable projects, and I'll get started with one. And we talked off camera earlier that actually the project was relatively simple, but I know a lot of people will at least know of the car, which is Andy Duffin's 3-rotor FD RX7, which competes here in New Zealand, but notably, and why I know it has a bit of a worldwide recognition, is that it did compete at World Time Attack Challenge over in Australia a few years back. So can you give us sort of a quick high-level view of what you did with Andy and what your sort of responsibilities were?
I got involved with Andy, and I met him for the first time basically when he sort of announced on Facebook that he was going to World Time Attack. And back then his car was ran down here in a local series called GDR NZ. Well, it didn't have a lot of aerodynamic, downforce devices on it, I guess. And it was more of I guess you'd call it a S2000 level car, which is sort of a much more basic FD RX7 race car. And obviously he wanted to take it from there to World Time Attack. So I got involved with him at that point, and it was just sort of at the start of when it was probably one of my first jobs really with Kinetic Sim in the motorsport area. And yeah, we didn't have a lot of time. I think we had probably about 6 months, 4 to 6 months to turn the car from what it was into something that was going to at least keep up with some of the open class cars at World Time Attack.
And he also had the disadvantage that over the years we've been going to World Time Attack, we've seen the power levels sort of skyrocket, and now sort of 800 wheel is probably the bare minimum you're going to need in those upper classes, and 1,000 plus is not unheard of. And he didn't have that opportunity. He's fighting with a naturally aspirated, peripheral ported 20B 3-rotor, correct?
Yeah, correct. So we didn't scan the car. We used a digital model that we found online of an FDRX7, and we created a CFD model based on that, because we knew that the means that Andy had to make the parts was going to be more basic, so we didn't need to scan the car. So we basically, we developed the front splitter, we did all the front radiator ducting, oil cooler ducting. We did a rear diffuser, but I'd say that was probably more to meet the rules. It's a long story, but to meet the rules locally than it was creating downforce, and spec a dual element rear wing for it. So it wasn't a large project in scale, but it was a really good example of taking a grassroots race car, and essentially we found probably 3 seconds just in the aerodynamics package alone when we first tested it at Hampton Downs.
That 3 seconds, just to give scale to that for people who don't know Hampton Downs, what's the sort of lap time before and after the aero improvements?
I think it was running about 1:09 at Hampton Downs, and we were sort of down around the 1:05, 1:06 mark.
Okay, I mean that's a substantial decrease in lap time over what is a relatively short lap. So that's why I just wanted to get that perspective there, and I think, I've been guilty of this myself, and I see a lot of my customers back through my old business, try and fix a lack of lap time with more power. And I just wanted to sort of get that perspective that 3 seconds, trying to gain 3 seconds by just adding engine power is A, going to be difficult, B, it's going to add a lot of stress and wear on the parts inside of the engine of the drivetrain. But the other thing that's really easy to overlook is as you add power, the car becomes more difficult to drive, where if you develop the aero package properly, it's a relatively low stress way of making the car faster. Would that be a fair way of describing it?
Yeah, definitely. And it's the biggest thing, I'd say, in my experience, having worked in sort of at the grassroots level in New Zealand for a while now, it's the biggest mistake everyone makes, is that no one really appreciates the amount of time you can save, or you can improve with a relatively small, well-designed package. That wasn't a complicated design. It wasn't a complicated thing to build. It wasn't expensive for him to build, and he found 3 seconds. So it just sort of shows that whole, I guess I always talk about the 80-20 rule, 80% of the gain with 20% of the cost versus designing something until you're, like a Formula One team. And the gains you can make at the end of the sport, people don't really appreciate.
I think that's probably one thing that World Time Attack has done a really good job of, because we've seen that development in both engine power, but more importantly, the aero packages that the top cars are running, and because that's so visible all around the world, and I think that's really helped the understanding of just how powerful a properly developed aero package can actually be. Obviously those cars there are at the cutting edge, but you dull that down, as you say, you don't have to be spending the earth at the grassroots level to get good gains. Now, I just wanted to mention that car again, as I mentioned, because it is something that I know a lot of our listeners would recognise. But moving into a project I'm quite keen to get some inside knowledge on, and this is a project that I understand you're doing in collab with Race Lab here in New Zealand, which is a BMW E21 Group 5 race car, which is a hell of a mouthful. Unfortunately, we don't have the benefit of pictures here, and we'll probably link to some in the show notes so those who have never heard of that car can get an idea of what we're talking about here. But for a start, what is this project? What is Group 5 racing? What is the BMW E21?
So Group 5 racing isn't a series that's around anymore. So it's not, it was a class of car that ran basically in Europe back in the 80s. It's what was essentially the precursor to the modern DTM championship. So Group 5 was a FIA class of car, and the cars that you would have seen racing in that were cars like the Zaxby Capris, there was the Zaxby Escorts, Porsche 935, and some BMWs E21, and they were very wild. They had small engines, massive turbos, wild body kits, big front splitters, big rear wings. Yeah, a lot of turbo lag. And so they were very impressive to watch. And that project essentially came about because at the time when I got involved with Race Lab, the owner was racing in the endurance series. He's passionate about BMWs, he's passionate about that era of car. And he wanted to essentially create a modern race car with the shell of, or the look of a Group 5 car from the 80s. And that's essentially what the design brief was. It was quite a basic design brief, and in the first instance, and at the start of the project, I was only doing the aerodynamic package on it. The intent was initially to use a Ginetta space frame chassis, which is an English race car manufacturer, and that was the initial plan. And it was to use a straight six BMW turbo engine.
As projects go, this has kind of gone in a direction all of itself, though. So that's neither of those are the current case.
No, and to be honest, it's probably the project with the most scope creep I've ever experienced. But it's all happened for very good reasons, and because of that, it's obviously been a longer project than was intended. But at the same time, the owner had other race cars that he was using it, so there was no rush for it, and it was more about getting it right and getting it done right. So that car, although I started out just with the aerodynamic package, it quickly turned into me doing the suspension, which then turned into doing the chassis, which basically then turned into doing everything. So that's been a massive project for me personally as well, just because I've got so much invested in it. But it was very cool. So it got to the point at the end of last year where essentially the design was finished. It was a steel chassis still. It still had the E21 chassis, but the front and rear were tube frame. The design was to use a Hollinger transaxle on it, and the engine was a GT3 twin-turbo V8 out of the BMW M6.
Yeah, that escalated quickly from the straight six.
Yes. We sort of talked about the engines a lot, and we mulled around talking about the straight six, the four-cylinder Beamer, and then we talked for a little while about a V6 EcoBoost, and then ended up this engine became available, and we ended up buying it, and that was what the design was going to be based around, basically. So
I just wanted to take a moment out of our podcast and talk to you about a couple of our courses that are both relevant to this podcast and I think you would really benefit from. These are our wiring courses, and this is an area that I know a lot of enthusiasts are a little bit scared of tackling on their project cars. And it doesn't matter whether you're maybe adding an auxiliary module to your project car at home, or maybe you're restoring and modernising the electronics on an old Formula One car. The skills skills of motorsport wiring are still exactly the same. We've got a couple of courses here that I wanted to just highlight. One is our club level practical wiring course. This teaches you how to design and construct wiring harnesses at an affordable club level. So this would be perfect for a modified street car or maybe a club level race car. On top of this, we've also got our professional motorsport wiring course, which is more aligned with making professional or mil-spec wiring harnesses they're often referred to. I'm talking here about fully sealed harnesses using Raychem DR25, concentric twisting for the construction, Tefsel wire, Autosport circular mil-spec connectors that are all sealed and booted with heat molded boots. This course will teach you the materials you'll need to be using, the techniques that you'll need to perfect, and you'll also learn a step-by-step process that you can apply to building your own harness, irrespective of what the project is for. By breaking the entire wiring harness construction job down into bite-sized steps, this makes it quick and easy to complete the individual steps, and in no time you've got to the end, you've got a completely designed, constructed and tested harness, and you're going to have the confidence that when you plug that in for the first time and power everything up, it's going to work exactly as you expected. Both of these courses are delivered via online video-based modules that you can take from anywhere in the world, provided you've got internet connection. This gives you the comfort of being able to learn at your own pace and at your own place. Once you've purchased the course, it never expires. You can rewatch it as many times as you like. And just to give you a little confidence as well with your purchase, we offer a 60-day no questions asked money back guarantee. So if you purchase a course and for any reason at all decide it's not what you expected, let us know. We'll give you a full refund of the purchase price. I'll put a link to these two courses in the show notes, and remember, you can use that coupon code podcast75 to get $75 off the purchase of your very first HPA course. All right, let's get back into our interview now. Okay, let's talk about the chassis options, because as we'll get into, it's escalated even further than what you're talking about here. But retaining the E21 base chassis and doing front and rear tubular subframes, there's obviously advantages in doing that in terms of flexibility with your packaging in the front and the rear of the car. Does it still become problematic in that you are dealing with an OE chassis in the middle, tying all that together, getting the strength, etc., the integrity through those components, and then also, just as importantly, if the car's involved in an accident, which we're racing, so it happens, is it then difficult to source replacement parts for the original chassis?
Yes, so that's one of the big issues with using a shell like that, is access to another shell that, first of all, isn't just a pile of rust. You know, we are talking about an older BMW chassis, so access to the cars themselves is hard. Access to decent parts for them is hard. So we got quite a lot of interest, essentially, out of that car when we were showing images of it on social media. There was a lot of people quite interested from all over the world in it, and people even putting their hands up and saying, sort of, you know, we'd like one of these. And we made a decision, essentially, to basically start from scratch again, in a way, to change the chassis and find something that was going to be safer but easier to make more than one of.
Is this where you went down the path of the Ginetta tube frame idea, or have we gone past that already?
Well past that by that stage. The parts of the chassis of the Ginetta that were being used were actually ended up being thrown out, and they bought a new Ginetta chassis and rebuilt the Ginetta they had for it, and that car's now racing in the endurance series. But no, this is well past that. This is sort of the end of last year,
Okay.
End of 2022.
So do you get to a point where, you know, you're sort of 75-80% tube frame, you've only got a bit of OE chassis left, so why not go the whole hog?
Yeah, just enough chassis left to meet rules of a class that needed a stock chassis. And then, we decided that to make more of them, to get access to a chassis. Getting an old E21 was just hard and expensive. And two, safety, it's obviously a big thing. For any gentleman drivers these days, it's a really important thing. And it actually simplifies a lot of things. So we started the search for 1, a new chassis, 2, a new engine, and 3, a new transmission at the end of last year. And essentially, although the look of the car and the external body panels and everything will be the same as what the initial design was, everything underneath, a lot of things underneath were going to change. So the engine was another thing which has changed. So essentially, BMW Motorsport have stopped supporting that engine. So finding more engines, if we were going to build more than one car, would be a problem. as well as that, we would have had to have remapped the whole thing because it's a locked out ECU. There were just reasons why doing our own engine program was going to be a better idea. So yeah, so we decided at the end of last year that we'd find a carbon tub. We thought initially about doing our own carbon tub, but that quickly got shelved.
So we're talking carbon monocoque tub here as opposed to tube frame. Obviously, there's still tubular structures coming off that.
Yes. Yeah, so carbon chassis, tubular roll cage, and a stressed transaxle in the rear now.
All right, let's dive into this a little bit. I mean, this is what we'd expect at the highest levels of professional motorsport, and it's not so common anywhere else. What is, for a layman who doesn't understand that term, what is this carbon fiber tub or monocoque? Can you give us a sort of an understanding?
I think you'll see these sorts of carbon chassis in most major motorsport series that aren't road car based nowadays. So it's a carbon fiber laminated chassis that's created in a mold, much like your body panels are now, but the whole chassis is done that way. And it's a very similar tub to what you'll see in a McLaren road car. The supercars of the day, the Paganis and the Koenigseggs and those sorts of cars have carbon chassis. So it's that sort of design that we're using here.
And what are the advantages of that carbon tub over a conventional tube frame chassis?
It's made in one. It's made in one go, so you don't have all the fabrication required with a tube frame chassis. Typically, they can be stiffer than a tube frame chassis in most cases.
Safe to assume lighter?
Lighter, yep, lighter. Well, not always, but most of the time lighter. It creates the safety cell for the driver as well, so it's far stronger in any sort of crash than a tube frame chassis, which is designed to deform and twist and bend to absorb energy, whereas the carbon chassis, it can have crash structures around it that absorb the energy. It's just a lot safer as well.
Okay. Now, you mentioned there you sort of briefly went down the path of looking at building, creating your own tub. Where are the complexities in doing so? How did that sort of get written off as being too big a job?
I think it's simple in your head, but when you think about running and racing a car and potentially internationally, even just the requirements for different regulations and rule sets, making your own chassis, we didn't really know what was involved with that. Hey, it's possible to make your own carbon chassis here in New Zealand for sure, but for what we were doing and knowing that there were chassis out there that we could buy, we quickly decided that the time frame we're talking about, that's a massive project in itself, let alone everything else that was going on. So yeah, we managed to find a really, really good chassis and a really, really good partner to work with in Japan.
So what was that? What did it come from?
So it's made by Dome. So the race car manufacturer Dome, who are a very well known, long-standing race car manufacturer out of Japan, and it's a chassis which is called, it's known in the Super GT series as the mother chassis. So it's the chassis that was essentially created back in the sort of around 2014-ish, I think, for the Japanese GT300 series. So for people who wanted to essentially make their own car and run in GT300, they could use this.
So it's a control part.
Yeah, this control chassis. So the chassis was designed in a way that you could have a front engine, you could have a mid-engined, and you essentially just bolt the front and back on however you want it, and you put your body over the top. So it ran quite successfully over there for many years as a Toyota GT86 car, but recently it's sort of fallen away, and now it's more GT3 machinery that run in that class. And obviously at the same time, the class above GT300, the GT500 class, they also run a carbon chassis.
If I remember correctly, as we were at Goodwood back in 2019 and we did a tech tour of one of the DTM cars, so it would have been a 2018 Mercedes AMG, I believe. And I was interested to learn there, if I'm hopefully not speaking out of turn, that that's actually the same control chassis in the DTM series back in that day as the GT500. So essentially the idea was that the cars could compete on a level playing field. Am I off the mark there?
No, correct. So it's the same, the chassis that is used in the DTM is the same chassis that's used in Super GT GT500. The manufacturer of the chassis is different now. So back then in Europe, the chassis were obviously made in Europe, but now those chassis for Super GT are made in Japan by a company called Toray Carbon Magic. So it's the same chassis. They use the same transaxle. Obviously, there's a lot of common parts that they use so that they could when they tried to bring those two series together.
All right. So we've got this carbon fibre monocoque. Any complexities or problems with making that work with what you're designing, or at that point are you sort of almost a back to square one with the design? You've changed the engine, you've changed the monocoque, you've changed the transaxle, I think you said as well. So is it sort of just let's throw everything out and start from scratch?
No, it's an adaptation. There's some changes that are needed. There's suspension geometry changes that are needed, but a lot of the design is still there. But things have gotten a lot easier as well. So things like the fuel cell, the fuel tank, which before was going to have to be next to the driver. That was something we would have had to have created ourselves. Now that's part of the monocoque, so that's in behind the driver. So all of a sudden we don't have to worry about that. We can just use what's there. And it also means we can have a passenger seat too now if we want to, whereas before we couldn't.
On that note, I've sort of always wondered about the location of fuel cells, fuel tanks, and obviously there's a safety element there. I've seen sort of some pretty nasty accidents in supercars in Australia, particularly before they went to the car of the future, where the fuel cells or fuel tanks were actually at the rear of the car. So of course a big rear impact, and you saw an explosion. So then they moved the fuel cell forward of the transaxle. Then, I've seen cars at World Time Attack, and we've considered this for some of our own builds, fitting the fuel cell beside the driver's seat. So, I mean, the upside, as I see it, keeps the fuel all nice and central around the centre of gravity of the vehicle. Is there some downsides there in the weight offset balance being literally side to side as that fuel load burns off versus having it more central side to side?
Yeah, I think for an endurance car, for any car that's going to run an endurance series, fuel burn and the weight balance is a big thing because the weight is moving from one side to the other. It's not something you can just necessarily tune out with anti-roll bars because it's a diagonal, basically a diagonal change. So it's not a straightforward tuning change. So I think the way that having the fuel tank and behind the driver, although you still do get a shift diagonally, I think it's probably still better as an option for an endurance car anyway. So for a World Time Attack car, having it next to the driver is fine. I think it's a decent location for it because the fuel tanks are so small. They've only got to run for a few laps. So
Yeah, exactly. An out lap, a flying lap, and then if they can get back to the pits without running out of fuel, everyone's happy.
yeah, that's going to be an interesting change this year with the use of slick tires. Is that the tires are possibly going to last more than one lap, so fuel tanks will probably have to get bigger.
Yeah, it's a whole different topic, which I'll leave because I do want to continue on this angle. So in terms of the transaxle, you mentioned that it's designed as a stressed member. So again, can you just clarify what that means for those who haven't heard that term?
So the previous design of the car had a tube frame rear end, so all the wishbones, the suspension, the dampers, and everything were mounted on a fabricated steel frame, whereas now and the gearbox, the transaxle would basically bolt inside that steel frame, and now essentially the whole transaxle itself bolts straight to the carbon chassis, and all the suspension wishbones, the dampers and everything bolt to the gearbox.
So much like you would see a Formula One car, for example, where the engine and transaxle are all a stressed member and everything bolts to those.
Correct, yeah. So it's exactly as you'll see it in a DTM car, now, or the previous generation before they went to GT3. The Super GT cars are like that. All the Le Mans cars are like that. It's the same, yeah, it's the same design now. So it's essentially taking it to that modern professional level motorsport design.
On face value, I would have thought that style of stress member versus having the transaxle actually located in a properly designed tube frame structure and then your suspension arms and everything coming off that, I would have thought that the stress member would have actually been maybe a little less rigid. I'm guessing I'm wrong here.
So the roll cage itself, most of the loads in those sorts of cars go through the rocker, through the damper, more so than they would, or at least twist torsion. So those rockers are supported by the roll cage still. So although it's a stressed transaxle, a lot of the load is taken still through the roll cage. Yeah, so it's a lighter package. You don't have all this extra tubes and fabrication required. So it's also simpler and probably maybe a little bit cheaper as well.
Okay. Also, another factor that is so easy to overlook is serviceability. And these cars require servicing work. So considering how difficult or time consuming it is to remove the transaxle for service work, strip down and inspect, etc., that comes into it as well. Is there a sort of upside or downside on either of those options?
No, I think they're about the same. I think you're always going to design a tube frame for the transaxle to drop out quite easily. So for these, you just unbolt the whole lot and the whole thing pops out. But the transaxle we're using itself is has got drop gears as well. So you don't need to necessarily take it out unless you're servicing it.
So for those who aren't aware of what the drop gears means, essentially two gears that you can relatively easily change, which effectively is almost like changing your final drive, like overall change in your gear ratios to suit a shorter or a faster track.
Yep, correct. Yep.
Okay. The transaxle clearly is going to then drive the location of the pickups that are available for the suspension arms. And I mean, I've seen these, they normally have multiple positions to give a little bit of flexibility. But does that sort of have too much downside in terms of your suspension geometry and design work that goes into that?
Yeah, so that is one of the big, I guess, one of the changes that we've had to make to the suspension is due to that change to the transaxle and where those mounting points are. You're obviously completely restricted in the product you use, but the product we're using is essentially the same gearbox as is used in the DTM and Super GT. So that gearbox has quite a range of pickup points because it is almost a one design item that multiple manufacturers need to adapt their own suspension and their own thoughts to. So because of that, it's still quite adjustable, but there definitely were changes to our initial design because of the transaxle and to be honest, it made quite a lot of changes to the whole rear aerodynamic package as well, because the location of the lower wishbones was dramatically different, and so our entire diffuser tunnel had to be redesigned. And to be honest, it was actually for the good, so it was a positive thing.
We'll come on to the aero package shortly, but just while we're talking about suspension, again, notwithstanding the design element of the transaxle we've just discussed, particularly at the front of the car, again, you've got a lot of flexibility, being that you're starting from scratch with a tube frame structure up there. Or does that come off the monocoque, actually? I shouldn't jump ahead of myself.
Yeah, so it comes off the monocoque. They're beams, as opposed to more like it's not so much a fabricated frame, it's the more beams that come off the front. The engine is packaged between those beams, and then suspension mounts to those beams. So it's a very tightly designed front. It is one part of that monocoque that we're using that was quite restrictive in terms of what sort of engine we could use in it.
Yeah, okay.
Many wouldn't fit.
In terms of the design within those constraints then of the suspension and the uprights, what are you doing? How are you designing that, and how are you validating that before any of the parts are actually manufactured?
Yep. So the design was adapted from the original design, which was essentially I ended up designing the pickup points, the geometry. I'll look at all the roll center and all those sort of kinematic details of the design, and then I've worked with Tim White on the geometry, and he's basically run it through the Optimum G software and checked all of it just to make sure everything's right, and we've made adjustments from there. So it's sort of been an iterative design process between myself and him working on those.
I assume beyond that, though, you're sort of using that validation to at least, hopefully, when the car hits the track for the first time, at least be in the ballpark. But then I assume there's still enough flexibility to then adapt the car to what you find under real-world conditions, or ultimately to suit a driver preference.
Yeah, definitely. So we'll create a window of adjustment that we sort of need in certain attachments of the wishbones to the chassis. So we will, create a mounting block on one of those beams that has enough adjustment to be able to move the wishbones wherever we want. Because in a way, the first car is still a development car, and that's something that obviously in the future, if you wanted to narrow those options down, you can, but it's always better to have them to start with.
Yeah, definitely. Okay, you've talked about the engine, and it sounded like you were bringing that development of the engine as an in-house project. Is that what I was sort of picking up there?
Yes, not so much an in-house project, but something definitely we're not buying anything off the shelf. It's going to be an engine that's created with an engine builder partner, but with us sort of driving some of the external components of the engine. So we're going to have to be involved designing the rocker covers, because they're going to be it's partially stressed. So the things like the rocker covers include engine mounting bolts and the whole front of the engine. It's a V8, so the whole front of the engine as well is the packaging means it has to be quite tightly designed. We haven't got big accessories mounted on the front or anything like that, so everything has to be kept as internal as possible.
When you take a production engine that was never meant to be partially stressed, and then you mount it like you're talking there with modified rocker covers, are there any considerations, are there any potential problems that you come across?
The engine itself we're using has been used historically as in this sort of package. So it's an engine that has been used with stress mounting. So it's we know that the engine we're using is a good engine. We just happen to be doing the development on it ourselves. So it's the same engine block and heads as is used in the GT300 mother chassis car. It's just we're not using the it's actually an engine derived from LMP2 and Super GT back in the early 2000s, the Nissan engine. So we're essentially adapting that design to work with our car, and we're building it locally.
Sounds like a pretty big project.
I think it's big, but it's not crazy. Like the only really bits we're changing or doing differently is really the mounting of all of it, and none of that's overly complicated from a stress point of view.
Okay. All right, let's dive briefly into the aero side of things. And I mean, again, we don't have the benefit of pictures in a podcast, and I would urge people to check out the links in the show notes to sort of get a sense of what we're talking about. But I mean, I'm not going to sugarcoat it. The Group 5 E21 probably looks like it's got the aerodynamics of a brick. And I can only imagine that aerodynamic understanding, efficiency, and development's come a long way since the 80s. Are you now kind of walking a tightrope between aerodynamic utopia and keeping the look and feel of this Group 5 race car?
I think I'll use the word compromise.
Yeah.
I mean, this project and this look in this car is designed around a concept that obviously isn't create the fastest car out to a set of rules. It's a car that's being designed to be competitive, but to look cool, to look like a car from the 80s. So because of that, there's obviously a lot of compromise aerodynamically. Just things like the radiators are mounted in the rear guards. They're not mounted out in the front like your normal race car would be. And so just creating the flow that needs to get to those things like that create challenges. But as you say, it's a brick. It's actually worse than a brick because a brick has a flat front. This has the front of it goes forward. It creates it sort of juts out, I guess. So it has created a lot of extra time that you wouldn't normally spend designing around those problems. So it's a lot of it's traditional. Like a lot of the aerodynamic design, especially under the body, under the car, was very much like some of the other cars I've done. But the top was a challenge. And actually this big change now to a carbon tub and the naturally aspirated engine from the turbocharged engine has meant some more beneficial aerodynamic changes in the front because there's now no longer a need for an intercooler. So we're actually ducting some of the front vent area through the bonnet to reduce the drag and reduce the effect of the front design of the E21.
Now, here in New Zealand, you've already mentioned he's going to be racing this in our endurance series, and there are some current GT3 machinery normally running unrestricted as well in that class, likes of AMG GT3, Porsche GT3, etc. I mean, I'm wondering if you can kind of give us some idea of how this is going to stack up aerodynamically versus a manufacturer-developed GT3 race car package.
I think obviously the manufacturer's GT3 developed cars are developed to a BOP, a balance of performance spec. Even if they're unrestricted in the local series here, in some cases, they're still a balance of performance sort of design. So a lot of the time, those cars are designed to have one part of their performance package better than the rest. So, if it's a Bentley, it's a large, heavy car, so they're probably going to have a bit more horsepower than everyone else. And I know for a fact that the cars like the McLaren, they're a lot more aerodynamically shaped, so they've actually got a lot less downforce than they could have, just to balance everything out. So I think this car is hopefully going to, I think it'll match up to most of them, and especially given the new rules that have recently been announced for the local endurance series here, where it's, they're restricted on fuel, they're restricted on weight. So if it's a lot faster per lap, then it's going to probably be killed on fuel burn. So I think it'll all balance out. It's not dissimilar to the current car that RaceLab race, which is the Renault RS01. That's a carbon chassis, stress transaxle. That's a carbon bodied car with good aerodynamics, and that's competitive with the GT3. So it's not dissimilar to that.
Yeah. Okay. In terms of getting the project to the start line, I guess, not even the finish line, from here, can you give us a sense of what that time frame's likely to look like? Or is that sort of how long's a piece of string?
The chassis has been ordered. There's lead times on a lot of the major components. So essentially, we are trying to have a car next year. So definitely, we want to be racing the car next year. So the client wants to be racing it in 2024. So that's sort of our timeline. Whether we get there or not, we'll wait and see, because obviously it's early days in the build, and in some cases the design as well. But we are full steam ahead. So
Oh, we look forward to seeing it on track and following its progress. Let's move on to the other topic I really wanted to cover today, which is you sort of wear two hats. We've talked about Kinetic Sim, but as a family, you also have Classic Revival, and there's a project in particular that I'm really interested in diving into there. So again, can you fill us in on the details? What is Classic Revival?
So Classic Revival is essentially, I would call it, it's not really a business, it's a family entity, I guess, and it's just driven by my father and my brother, and the passion for not just cars and racing cars, but also road cars as well, and just the passion for sort of restoring and showing some cars that we've, I guess, inadvertently collected over the years.
And independently. It sounds like it's an accident.
No, not an accident, but a lot of these cars we've had for a long time, and not something that I guess I think we collect for the sake of collecting. It's just cars that we're passionate about, and that we like getting, and some of them are quite unique. So people do like seeing some of them. So it's really driven by that whole entity is driven by us loving restoring race cars. We love running race cars. We do most of our motorsport now overseas, I guess. Most of the stuff we do, we take the cars overseas to do. There is a real shortage of uses for them here. So that's really what it's about for us, is just, the love of doing that sort of thing. So yeah, we've got quite a selection.
I want to dive into one in particular, and I actually stumbled upon this and never actually got the opportunity to come back and feature it when we were at Festival of Speed back in 2019, which is the Leighton House 891. And I'll put my hand up and say I'm definitely not an expert on historic F1 machinery. At the time, I didn't know very much about that car. Since that, I've read Adrian Newey's book, How to Build a Car, probably, I don't know, 6 or 8 times by now. And Leighton House was sort of his entry back into F1. And I think he started with the earlier model, the 881, but you've got the 891. So for a start, how does someone come to own a historic F1 race car? That's probably a question a few people are wondering. Can you do they pop up on eBay, or is there some super secret F1sales.com website, or what?
To be honest, so my father owns the 891, and the story of how we got that goes all the way back to, I guess, around 1991, I guess. And my brother has a CG9 11B, which is the 91 car. And the way he got that is very different to the way we got the 89 car. So the 89 car is essentially back in Leighton House days. So Leighton House was a sponsorship. Essentially, it started out as a sponsorship. So it was a Japanese company, and they sponsored the March Formula One cars. So the manufacturer back then was March. And during that sort of 88, 89, 1990 era, Leighton House ended up buying March. So the cars essentially became Leighton Houses when initially they were Marches. So essentially the person who owned Leighton House got into a bit of fraud trouble, and he ended up being put in jail. So at that point, essentially in 91, the team went bust. The mechanics were owed a lot of money. People were owed a lot of money everywhere. And that car, the car that we have, essentially ended up with one of the mechanics as a form of payment. So there were a whole bunch of boxes of parts and a chassis that ended up on their way to Australia, actually. I think it was Perth. And the mechanic rebuilt it in his garage. And he ended up selling it to, obviously, a very well-known Kiwi motorsport identity down here called Kenny Smith. So Ken bought the car, and he actually did a lot of demonstrations with it. So it's been in New Zealand for a long time. He did a lot of demonstrations with it around the local motorsport scene here in the mid-90s. I can remember watching it as a kid, being driven at Pukekohe, Manfield. I remember it at Manfield, and he was doing a demonstration with Sir Roger Freeth in the CRC Indy car. So yeah, it's a car that's been here for a long time, and it ended up being sold. Kenny ended up selling it to a guy called David Dickers, who is the guy who owns Roden Cars. So it ended up spending some time down in Mount Lyford, which he's based at inland of Kaikoura there, and we ended up buying it off him. So
it's done a tour of New Zealand, really, and Australia.
It's done a tour of New Zealand, yeah, and it's had, we got the car essentially in the state of it having been rebuilt back in the early 90s and being demonstrated. Kenny demonstrated it. I don't think David demonstrated it. It was driven once at Ruapuna.
So give us a sense of the condition when you got it, because I mean, obviously you can't ring up Leighton House that don't exist, or March, or anyone for that matter, and buy spare parts for the car. So the condition obviously really impacts what you can sort of do with it. So yeah, let us know.
Yeah, so it was in an original correct condition. So all the parts on it were correct. It hadn't been stuffed around with, there wasn't anything missing. There were a lot of spare parts with it. We had a spare engine. So we were very lucky in that respect. And yeah, it makes it significantly easier to restore when you have everything there. And so my brother Andy, he is a fastidious restorer. So he restored the car over a couple of years down here, and yeah, everything was done. Everything was rebuilt. The engine got sent back to Judd in the UK, and they rebuilt it, but everything else was done locally. So it's just a long process. Like everything's correct, so it does make it easy to restore, but it's just a long process. Everything has to be checked, everything has to be crack tested, every coating redone, and a lot of the coatings are stuff that you actually just can't get down here. So there's a lot of waiting for parts from Europe, and then a lot of collection of stuff to run the car. So running the car is a whole other story.
Before we get into running the car, just for sort of historic relevance, as I understand it, these cars, the 881 and the 891, this was in the Formula One, the original Formula One turbo era, but Leighton House actually went with the naturally aspirated engine package. So they were kind of at a massive performance deficit in terms of engine power. But as I understand it from Newey's book, that was their advantage, was the aerodynamics, because a lot of the Formula One teams that were running these turbo engines really didn't worry so much about the aero and were really trying to fix everything with the big stick that is more horsepower. So have I got my history about right there?
Yeah, correct. So the 881 was a pretty groundbreaking car. It was very small, it was very light, and it was Newey's trademark, I guess, aerodynamic shape, where he sort of almost designed the chassis around the driver. And the 891 was a big extension of that. So the 891 is very small. Fitting in it, I don't fit in it. My brother does. Even Ivan Capelli, who came down and drove it at Adelaide for us a few years ago, even he was a bit tight for it now. He designed things so tightly that in the initial test for the car, that the drivers struggled to change gear. They were actually smashing their knuckles on the cockpit. So they had to essentially create a small bubble around the gear lever on the cockpit just so they could change gear, and that's how tight things were. The 891 was the first car to have the raised nose, so that whole aerodynamic principle about sort of raising the nose. And so that was, those really early days. And when you look at an 89 and a 1990 car that were Newey designs, and you compare that to the hero cars of Newey's era, like the FW14B of Williams.
There's a family look and feel that's followed Adrian through his career.
Yeah,
With obviously within reason, with rule changes, etc.
yeah, exactly. Yeah, and everything's on the car's so light. So if you look at anything on the car, it's going to either be carbon fiber, titanium, or magnesium. Like, that's about it. Like, all the little tiny bolts, you just think of the amount of time and unsafe for the mechanics, a lot of stress and worrying about whether things are going to break, because you got this new hotshot engineer designing everything small. You're going to be worried that it's going to break. But I think the car complete only weighs 475 kilos.
Wow, that's insane.
And when you look at the size of the thing, the physical sort of envelope of it, it's huge. The wheels and tires and everything. It's big. It's a small car, but a big car. And when you think about that weight with a full, 640 odd horsepower V8 in it, it's pretty small.
Yeah. I mean, I think that the minimum weight, I can't remember what it is for 2023, but I mean, the size of the cars and definitely that minimum weight is sort of bloated out over time, obviously.
It's nearly double, I think, isn't it? Nearly double that.
Obviously, a lot more technology and moving components to fit into the current crop of cars, but I mean, that is a massive difference. Just want to talk a little bit about the engine. So you mentioned it's a Judd V8. Obviously, it's getting on a little bit now. How do you go for serviceability on an engine like that? Can Judd still supply parts off the shelf, or is it made as required?
I think at the time we were one of the first people to go to Judd and ask them to restore one of those engines. So there were a lot of parts that had to be made, but luckily there were still employees at Judd who built the original engines back in the late 80s, early 90s. So there was quite a strong knowledge there, and they did have old MS-DOS operating system computers to run the ECU and to check everything on the dyno. So we did look at rebuilding the engine locally initially, But we quickly realized that after talking to Judd that it was going to be probably just as cheap for them to do it. And then you'd know it was, you can't beat the original manufacturer for rebuilding something like that, especially a company like Judd, who's still really strong in that whole engine motorsport market.
Probably also a little difficult to download a PDF with step-by-step assembly and disassembly instructions like we can for just about any production engine. So, yeah, I think that's probably a no-brainer. In terms of that, I'm assuming the parts that you'd really struggle with would be if any of the actual the main castings got damaged, the engine block or the cylinder heads. I'm assuming those would be pretty difficult to source now.
They were all fine, and we had the spare engine as well, so we had 2 engines and a number of spare parts, so access to the cast things was fine. That's certainly a problem with the other Leighton House car we've got, and the engine in that, because the first engine we got, when pulled apart, it was quite cracked. So that is a common issue with those sorts of engines of that era, because they did go through a lot of engines. So you never really know what you're going to end up with when you buy something.
Yeah, sure. I didn't have the engine limits per season that we see now, I understand.
I've been told that by one of the original mechanics that some weekends they'd go through 7 motors.
It's an expensive weekend.
And I think this car ran in, I think it was 7 Grand Prix in 1989. And one of its most successful outings was at the French Grand Prix. For some reason, the Newey's design really suited that circuit, and it was running second at one point. The following year, the 1990 car actually finished second at that event, but it was running second before a failure. And one of the reasons that it did so well there is that they knew the engine wouldn't last, so they knew the engine would not go the whole distance. So they basically sent the drivers out and said, go as absolutely fast as you can for as long as you can, without caring about the engine, because we know it's not going to last. So just get up as far as you can to get in front of the TV, to get the exposure.
Sure.
Yeah. So that they just knew they weren't going to finish because of the reliability problems. But yeah.
Somewhat kamikaze effort that we probably wouldn't see these days. I'm assuming as well, obviously the modern crop of F1 cars, you're not going to be able to buy one of those probably with the engine package, let alone run it. But even if we go back to the last generations of the naturally aspirated engines, at that point they were all running pneumatic valve trains, and I'm guessing really for a privateer team, just about impossible to run one of those, even if you could get hold of it. Is this sort of getting towards the last of those generations where a privateer team could run the car?
Yeah, I think that certainly it's not a complicated car to run. It still has an H-pattern gearbox. It's still, like I say, your standard valve springs. They were only revving to 12,500 RPM. So you haven't quite reached that era of the pneumatic valve springs, which was sort of more of around your 91, 92. But I think one of the big things which really complicates things going forward, more so even than the pneumatic valve springs and the engines, is the hydraulics. So when you get to that mid 90s era of hydraulics, when you're talking about semi-automatic gearboxes, you're talking about active suspension, you're talking about all those things. That era of cars in that mid 90s would be very complicated to run. But then that would end up getting easier again in sort of early 2000 Formula One cars.
Once all of that technology got removed.
Yeah, got removed. So there is an era there of complexity, which even now is still complex, but then there is also an era of cars that are reasonably straightforward to run.
One of the things that sort of goes hand in hand with running a car like this is preheating all of the oil and water before the car can be run, not to mention tyre warmers as well. Can you tell us sort of briefly what does the process look like if you guys want to take that car out and go and do some laps?
So it starts quite early in the day. So if we only use it obviously for demonstrations. So typically they're around lunchtime, which helps us because it does take sort of 2 to 3 hours to get everything up to temperature and get the car running. So we'll always, obviously we have water heaters, oil heaters, and obviously tire warmers as well. You don't really want to run a car with slicks that size that are cold. So yeah, we typically take about 2 hours to get the car up to temperature and get it started and get it running. It gets easier for every session after that through the day. So it's really only that initial warm up because we keep them warm.
So it's still got some residual heat after it's run for the first time.
Yeah. And then we'll plug the water heaters back in again before each run, but we don't have to reheat the oil and so on. So because to reheat the oil, we actually pull all the oil out of the car. So the oil doesn't stay in the car. We use a system where the oil stays in a separate oil heater. We heat it up, then we put it in the car. And then once the run's done, we take it out again at the end of the weekend, or the end of the day. Sorry.
Oh wow, okay, that's quite the rigmarole. There's a sort of urban legend, urban myth, if you like, that just keeps coming up. We've got a fairly thorough sort of number of people on our social media that come up with this every time we mention anything about F1 engines, and particularly the preheating of the oil. And I think that urban legend goes something along the lines of the engine is physically seized at room temperature, and it cannot be rotated. And if you don't preheat the oil and water, then there's no way that the engine will turn over. I mean, to me, that doesn't make sense because, for a start, how are you even going to assemble the engine? Yes, the tolerances obviously do change, but can you talk us through the reality of that? Are these engines actually seized at room temperature?
No, they're not seized. They're certainly not something you want to start without heating. But that's just more from a longevity. You don't want to damage things. You don't want you want to make sure the oil is warm, that everything is at its operating temperature. Especially in this day and age as well, like just actually getting the engines to last a long time before rebuild, just at the cost of doing them. So I think you're always going to do everything you can to make sure the engine is not damaged. That's always going to be your number one. So if that involves heating everything up, yes, definitely you'll do it. But will the engine turn over? It'll turn over.
Yeah, I'm definitely not advocating that it started at room temperature, but just wanted to get some clarity from someone who's actually dealt firsthand with an F1 engine. So glad we got that cleared away. One of the other elements with cars of this generation is the electronics, and we've talked to people before who have done essentially an electronics upgrade or retrofit on the older F1 cars because they can't get hold of the software. You sort of mentioned there Judd having access to the original software. So what have you done there? Nothing by the sounds of it. You're just locked out of that ECU and don't deal with it?
Yeah, for that particular car, we don't stuff with that stuff. We it's not something where we're running it competitively anywhere, so we're only using it for demonstrations. So we don't need to try and extract the most out of it. The maps and everything that are in it are fine for what we use it for. So for that particular car, the entire wiring harness is all completely original. The ECUs and everything, the ignition box is all original, and we have spares of those. So if we have issues with one, we just swap them out. So we can get into it. We can get into it if we wanted to. We do have the software, and we do have, if we wanted to go and get an MS-DOS operating system computer or try and set one up on a modern computer, we can do that, but it's not something we needed to do. That's completely different than what we did with the Porsche 962. So one of the other cars that we restored, the 962, we did that retrofit. We did an entirely new wiring harness. We had the original Bosch Motronic ECU box remachined, and we fit a Motec ECU and boost controllers inside that box to make it look original. So we've done both options because that car was raced. We raced that car, and we wanted the data acquisition, and we wanted all that stuff. So it depends what you're using it for, but yeah, you can do both.
Yeah, and technology's obviously come a long way in that time, and the modern crop of ECUs do give a lot of advantages. We've talked on the podcast in previous episodes about exactly that element. I guess you do have to weigh up as well. You've got what is an appreciating car that's worth a lot of money, so anything you do to it, you need to kind of keep that historic correctness in the back of your mind.
Yes, you keep everything. You obviously doing that with the Porsche, we kept all the original stuff, and that's why we even remachined the case. You got to see one to appreciate it, but they're a big box. They're a very big box, and you have to machine it from billet, so it's a very big piece of aluminium you start with. So we do keep everything, all the wiring looms original, everything, and then yeah, it can be turned back into whatever you want later on if need be.
Yeah, makes sense. One other element I'm quite interested with the 891. This was sort of in the era, particularly with the turbocharged cars, that the teams were running some pretty exotic fuel mixes, probably not something that's going to do great things for your health. Obviously, this one was naturally aspirated, so maybe not that requirement, but what fuel do you run it on? I'm guessing you can't get access to maybe what it had back in the day.
Yeah, we have to import the fuel from Europe for that car and the Porsche as well. Yeah, we it's like Porsche, for instance, you mix it with toluene, so you do have some exotic mixes there. But a lot of the modern fuels, the more specialized ones, you can still run them on. It's not something you get from a pump or even from avgas or anything like that, but it is available. The difficulty is that how often we run the car, so getting the fuel down here and keeping it stored and all those sorts of things to run it regularly is an issue.
Well, we say regularly, but I'm guessing this is sort of the order of a few hours of use a year, maybe at best.
Basically, yeah. And to be honest, we'd probably use it more often, but there hasn't been a demand to use it here. We do have more offers of invites, I guess, from overseas, and we do locally.
Now, it's one thing to sort of do a one-off exhibition run solo, maybe up the driveway at Goodwood Festival of Speed or wherever that may be. Does it actually get used in wheel-to-wheel racing as well? And is that sort of pretty terrifying, if so?
No, it doesn't. No, we're not actually allowed to.
Oh, really?
I believe, I'm not sure if this is still current, because obviously there's been some big developments in circuits down here, but no circuit is allowed to run a Formula One car here of that era still, I think. I think the limit's around 1985-ish, I believe, but it needs a certain category racetrack to run it with like a medical facility or something like that. So to actually race them, I'm not actually sure. Maybe we can, but it's not certainly something we'd try. There's no need to, really, is there? Because it'll be faster than everything that's here.
Nothing to prove and lots to lose, essentially.
Yeah, exactly. It'd be cool to set some lap records, but still, it's yeah.
The Porsche that you've mentioned, though, the 962, it's a Group C car, is that correct?
Yeah.
But that, you say, was used in competition. So, I mean, the same
Yes.
sort of goes. You've again got essentially a very, very expensive car. Is that sort of terrifying to watch?
Yeah, that was sort of my father's bucket list thing to do, is to get a proper Porsche race car and race it in the big tracks and overseas in Europe. So we bought that from a collection in Europe. We brought it down here and restored it. And we raced that at the Spa Classic, at Spa-Francorchamps, Le Mans Classic. And we took that one to Goodwood in 2018. And we also did Rennsport Reunion in Laguna Seca in the same year. And then Adelaide Motorsport Festival actually as well in the same year. So we had a big sort of...
That's a big year.
A big year. And like the highlight of that was Le Mans Classic. Like, having been to quite a few now classic race car events, there's nothing that beats Le Mans Classic. It's just the most overwhelming, biggest classic racing thing in the world. Like, I try and compare it to local motorsport, and it's the same. You've still got the tents, you've still got the race cars and the tents, but every race car there's worth over $1 million, and some of them are 20, and doing that race at that place in a 962. I'm very jealous because my brother and my father drove. I didn't, but my brother was doing over 300 at least 5 times in a lap. And I've got the videos of that are on the Facebook page and stuff of those laps, and it's just, you see it maxing out in revs in 5th, and that's 310 plus, and he does it 5 times in a lap. So
yeah, I guess that's
pretty cool.
Definitely a once in a lifetime experience. You'd be pretty happy with. All right, Dave, we'll move on towards wrapping this thing up. I do want to respect your time here. We've got the same 3 questions we ask all of our guests. And the first of those is, so what's next in the future for you and Kinetic Sim, maybe Classic Revival?
Yeah, so I think for Kinetic Sim, I'm sort of starting on getting into making some parts. I think that's probably the next phase for what I'm doing there, is a bit of a rebrand and actually making some performance and aero parts. I'm going to start with some wings. There's certainly plenty of competitors around, but getting access to them down here in New Zealand can be quite challenging and expensive, and there aren't actually that many options. So I'm going to start doing some wings to sell locally, and just getting into more that side of things, more so than just restricting myself to essentially selling hours. And that's sort of what Kinetic Sim, I think, is going to get into this year. And yeah, and in terms of Classic Revival, it's been a bit of a pause, really, because of what's been happening in the world with COVID. But we are taking the Leighton House overseas again, so we are going to be heading over to Aussie in March for the festival over there. So just starting to get back into it. And I'm personally just finishing restoring an RX-7 for a concours down here, so a road car, something a bit different. But
I've been watching that on your Instagram, and I'm very jealous, given that we've got our own FD RX-7. Yours is just at a slightly higher quality.
Yeah, it's I don't know why I did it, to be honest, but it's actually this coming weekend, the event. So.
All right, next question. Is there any advice you'd give to a younger version of yourself, or maybe one of our listeners, to help fast track where you've got to in your career, and maybe, if there were any, avoid some potholes or problems you came across?
Yeah, that's a tough one. There certainly were a lot of challenges early on, because I was trying to create an industry here that wasn't there before. And I've sort of pigeonholed myself into quite a niche area of work. But it's just about persistence, really, isn't it? I think just keep bashing away, even when the work mightn't be there. Like, I'm quite an introvert, so you got to turn yourself into a bit of a salesman if you want to do this sort of work. It's not easy. And yeah, just give it a crack, take a risk.
Give it a crack and take a risk. I mean, I think that's pretty solid advice for anything in life. Nothing worth doing is easy. So, if you're not prepared to give it a crack, then obviously you're never going to find out.
Like for me, the big risk for me at the start of doing this sort of work was essentially buying a seat of CFD, which in itself was a very expensive investment. And so that was the biggest risk to start with. And it takes things like that to really get ahead, I guess. Yeah.
Yeah, sometimes you sort of got to take that risk and hope that it's going to pan out. Although maybe an educated hope, not just
yeah, you got to be smart about it, but yeah, and that's the way with things like cars as well. Being smart about what you buy and what you do and when you do it.
All right, Dave. Last question for today: if people want to follow you and find out what you're up to, how are they best to do so?
I'd say best is a mixture of Facebook and Instagram. I think Facebook Kinetic Simulation and Classic Revival is on there as well, and on Instagram aero_Dave. That's got quite a variety of things, basically all cars or sometimes some yachts and every now and then a few planes, but yeah.
Usually interesting though, I find.
Interesting, yeah. I try and keep it interesting, yeah.
All right, Dave, we'll put some links in the show notes so people can find those accounts really easily. Thanks again for your time and we wish you all the best.
Yeah, thank you very much. Appreciate it.
If you enjoyed this episode of Tuned In with Dave, we'd love it if you could drop a review on your chosen podcasting platform. These reviews really help us to grow our audience, and that in turn helps us to continue to get more high quality guests. To say thanks, each week we'll be picking a random reviewer and sending them out an HPA t-shirt free of charge anywhere in the world. Also, this is a great place to ask any questions you might have, and I'll do my best to answer them if your review gets picked. So this week, a big shout out to Marco from Canada, who has said, I wanted to thank HP Academy for this podcast, all the courses you offer and all the knowledge you share on the various social media platforms. You really are making a change in the tuner and motorsport community. I've listened to every interview on this podcast and some of them multiple times. I patiently wait every week for a new episode to air, and I especially enjoyed the discussions with James O'Connor and Oscar Zelaya. Those were two of my favourites so far. Thank you. Well, thanks for the great feedback there, Marco. I'm really pleased that you are enjoying the podcast. And if you reach out with your t-shirt size and shipping details, we'll fire a fresh tee straight out to you. All right, that concludes our interview. And before we sign off, I just wanted to mention for anyone who's been perhaps hiding under a rock and hasn't heard of High Performance Academy before, we are an online training school and we specialize in teaching a range of performance automotive topics, everything from engine tuning and engine building through to wiring, car suspension and wheel alignment, data analysis and race driver education. Now remember, you've got that coupon code. You can use podcast75 at the checkout to get $75 off the purchase of your first course. You'll find our full course list at hpacademy.com/courses. Important to mention that when you purchase a course from us, that course is yours for life as well. It never expires. You can rewatch the course as many times as you like, whenever you like. The purchase of a course will also give you 3 months of access to our Gold membership. That gives you access to our private members only forum, which is the perfect place to get answers to your specific questions. You'll also get access to our regular weekly members webinars, which is where we touch on a particular topic in the performance automotive realm. We dive into that topic for about an hour. If you can watch live, you can ask questions and get answers in real time. If the time zones don't work for you, that's fine too. You're going to get access as a Gold member to our previous webinar archive. We've got close to 300 hours of existing content in that archive. It is an absolute goldmine. So remember that coupon code podcast75. Check out our course list at hpacademy.com/courses.